Okay, so I hope you know by now, but your textbook is made up of two sections. The one is principles and the other one is practice. And most of the videos, actually all of the videos that I've done thus far have been from the principles section. Now we're going to look at questions, problems from the practice section. And I'm going to start off with review questions. Actually, I've written review problems here, but actually it's review questions in your practice section. And I've just taken a sample of questions. Remember guys, you need to do as many problems, as many questions as you can, so that one important thing is to find out what you don't understand, so that you can then go and get some help. Okay, so I've taken some samples of questions. Remember, this is chapter 2. Motion in one dimension. Okay, so let's look at question 8. Describe how to determine the x component of the position of an object. So we're looking at the position of an object at a specific instant given A, the graph of position as a function of time. Okay, so if you've got a graph, say there's your position time, and your graph looks something like that. There's your position as a function of time. How do you determine the x component of the position at a certain time? Well, very simple. You pick the time that you're interested in and you go up where it hits that curve, and that is your position at that time. B, if you're given an equation, well, say now your equation of your curve looks something like this: 2 plus 4t squared. Right, that is the function, that's the equation of your position time. So, and you wanted to find what is the position at a certain time. Obviously guys, you just plug in the time in there and you'll get your position. Okay, remember these are review questions, they're not particularly difficult. Okay, 9 says, in an xt curve, what is the significance of a steep slope as opposed to a gentle slope? So if there's your xt, what is the significance of a steep slope versus a gentle or a gentler slope? Well, we know the steeper the slope, we know that velocity is change in x over change in time. So your velocity is related to the slope of your position time. So the steeper the slope, the higher the velocity. So if you drew a velocity time curve there, for this one you would have a higher velocity, for this one you would have a lower velocity. Okay, what is the significance of a curve that slopes downward as you move from left to right? Downward from left to right, well, that is a negative slope. So it's a negative velocity from left to right along the time axis. Okay, as opposed to a curve that slopes upward. So a slope that moves upward from left to right is positive velocity, that is negative velocity. Okay, what's next? Is displacement a scalar or a vector? We know displacement is a vector. Distance, scalar or vector? Distance we know is a scalar. Can distance be negative? No, because it's always a positive scalar. Can distance traveled be negative? No. What is the purpose of a unit vector? Unit vector I. So, well, for one, a unit vector I is a special case of a vector with a magnitude of 1. It's always pointing in the positive x direction. And the purpose is to give some kind of scalar value a direction. Right? So if we said that 20 meters, what does that mean? It doesn't really give us much information, but if we say 20 meters I, we know that we need to walk 20 meters in the x direction. So the unit vector gives a scalar value a direction, or gives a magnitude a direction. Okay, What is the shape of the xt curve for an object moving at a constant velocity? So if you've got a constant velocity there, your velocity time curve, what is the shape of the position time curve? It would look something like that, right? So it's got a constant positive slope. So remember, the derivative of your position time is the value of the velocity time. And finally, I think, yes, I'm just going to look at 26. In a velocity time graph, what is the significance of the area under the curve for any time interval tf minus ti? So if there's my time initial, and there's my final time, what is the significance of this area under the curve? The significance is, well, let's have a look here. So Vx is what? Delta x over delta time, which is x final minus x initial over t final minus t initial. So that's your velocity. So our velocity times our change in time, our velocity times our change in time is equal to our change in position. That's our delta x. So our change in position is equal to velocity times change in time, which is what? Velocity, there's my velocity, is my height, and my change in time is my breadth or width. So the area under the curve is height times breadth is height, there's my height, and there's my breadth. So the change in my position is equal to the area under the curve. Area under curve. Velocity time curve. So if I can calculate, if I have my initial position, and I want to find what is my final position, if I want to find that delta x there, then I need to calculate what is the area under the curve, because then my initial position plus the area under VT curve is equal to my final position. Okay? All right, good luck.